let me actually show you, or let me share my screen. Da, 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 da. Screen share, go live. Can everybody see my screen? Okay. A second, my audio is a little too loud. Can everybody still hear me? So what I'm doing actually is that this is Windows. This is Windows, and I'm running IntelliJ. And if you'll notice, see that squiggly right there? That's not what it is supposed to look like in Windows. So, in fact, let's exit out of this for a second. Let's completely exit out of this. So this is something called Windows Terminal, which is actually a nice terminal. It's like a half decent terminal for, well, let's see. Ubuntu Subsystem for Linux, WSL, which is what this is running, PowerShell, command line, some other stuff, and guess what? Other tabs. It seems to run reasonably. Now, this is WSL, right? ls. This is Linux running inside of here. Like this is an actual Linux environment. And if I do IDEA, ta-da! So this is actually IntelliJ IDEA that's running out of my WSL. And by the way, let's say that I want to do something like open up Sublime Text and edit.bashrc. Ta-da! So I'm actually running these applications inside of Windows. This is Linux applications inside of Windows with GUIs. It's really pretty neat. I haven't used this for a lot, but at least it seems to be relatively usable. VS Code, I'm using a little differently. VS Code actually, notice WSL Ubuntu, you can run VS Code also directly from WSL the way I ran it before. In fact, the way I launch this thing, and I'll close it up and show you guys, the way I launch this thing is I go to the, here we go, Dotty test, and then I do SVT launch IDE. And basically, this is the same SVT command that I would be using on OS X, same command that I'd be using on Linux, and it's launching it. Let's close that exterior window. Here we are, and it's actually connected to WSL. So how many of you are using Windows, by the way? I'm just curious. Oh, no worries. I have an OS X environment setup video that again I'm about to post. It's actually it's actually a substantially shorter setup on OS X. Um, anyway, so um, oh sweet, sweet, okay. Then you've done most of what needs to get done. Um, the only other thing is you need to do a separate setup for to get I don't know. Did you set up an X server running with uh, with Xming or what is it called? Um, I forget what that other thing is. But can you run graphical applications inside of it? Okay, so that's actually my second setup video is how to run graphical applications from WSL2. And by the way, it has to be WSL2. WSL1 does not support it. WSL1 does not support many things, unfortunately. So that's an important quirk there. Anyhow, so yeah, so just you can take a look at the environment setup videos I've posted. Um, they basically everything that I've got here, they explain how to set up. And so, you should be able to get to where I am right now after you run through those videos. Anyhow, so um, and by the way, if there's anything about those videos that's confusing, please let me know. Um, I'll definitely correct anything that needs to get corrected. But I think this is really cool. I think the fact that this is actually now possible in Windows, this is really cool. The one thing that I haven't explained yet is how to set up Docker in here, but the parts of Quill that you guys are going to be working with don't require Docker. But it's actually interesting. WSL2 is a real Linux kernel, so it's powerful enough that you can actually run Docker inside of it. And it's actually cross-integrated with Windows as well. So you can have Docker in Windows and Docker in WSL, and they work together. So again, just more neat things. And it's especially important if you're integrating with external containers or external utilities, and you're running something like IntelliJ. The Windows IntelliJ, for example, wouldn't necessarily integrate with the Docker if you wanted the integrations, wouldn't necessarily integrate with the Docker running inside of WSL, or wouldn't exactly integrate with a servlet container or something running in WSL. That's what makes this so neat. This is coming straight out of Linux. It's like a Linux application. Anyhow, all right, so the next part of what I wanted to show you guys is basically introduce how some of this parsing stuff works and how the Quill Parser works and where um, basically what you guys need to do with it. Now, last time what we did was we went through a macro, right? We went through a macro and we looked at some ways that you can use a macro to match an expression using quasi-quote. So, for example, we wanted to match something like foo.to uppercase, and we wanted to match this particular piece of code. And once we've matched this particular piece of code, what we wanted to do is, change it to substring2 or some trivial thing like that. Where the idea is that what macros allow us to do is that macros allow us to basically change arbitrary code. So let's actually simplify this for a second. In this case, let's just return this. So in this case, if you're doing to uppercase, then make a substring. Otherwise, let's say just return the initial expression that you've passed in. And well, let's not println the expression was not matched, and then just return expression. So, does everybody remember what this stuff does, how this stuff works? Or should I go over it again? Basically, quasi-quoting. How quasi-quoting works, how it matches the tree. Is there anything I should clarify about this before going forward? Because once we okay, okay. So the thing about macros that we've ran through before is that let's get rid of this, get rid of this. The unique thing, and actually let's open up a Sublime. The unique thing, oops. Whoa, what is that? Oh, ignore. The unique thing about macros is that if there's some kind of function, right, and inside there's an expression, let's say you have a string called foo, right, and then you do something like foo.toUppercase, right? So a normal function just gets the return, right? So when you actually define this thing, right, it takes a string. Let's say it returns a string or something like that, or it can return any. This function inside of here, it will only get the result of this expression. It will not get the actual code that went inside, right? So that's just how programming works, right? So it's a string that went in. We know nothing about how that string was computed. We know nothing about what expressions went into computing it. We just know that it's some string. So we can do something with it, right? We can say something like that. But we don't know what happened initially, right? As opposed to a macro function, where we have some kind of thing here. We know it's a string, or we know that the output is a string of the thing that we passed in. But we know more. We know that it's not just a string. We know it's some kind of expression. It's some kind of expression that yields a string. And when this thing returns, it's also some kind of expression that yields a string. This is the definition of a macro function. Now, notice that this is an expression that's typed. The other way that you can be even more abstract about this, by the way, is that you can pretend that it's something that's not typed, that it's a generic tree, right? Now, do you guys remember what abstract syntax trees are? Should I go over that again? Okay. Okay. So let's see if I can. Let's try to go back here. Forget what, oh, Jamboard. There we go. Come on. Okay. All right, remember this? When we code, we write some code initially. That code turns into an abstract syntax tree, right? When some function is parsed. So we have some function p.walk. That function is parsed. How is that function parsed? Well, it's parsed into some kind of data structure that a compiler can understand. Every piece of code, even before it's translated to machine code, it needs to be parsed into some kind of data structure that a compiler can understand. Right? What is p.walk? Right? We say something like we write some code saying p.walk. And then let's say to Main Street briskly. What is that? What does a compiler see? So we have to parse this code as a first step into something that the compiler can then reason about through a series of phases that ultimately end up as machine code. So what does a compiler see? Well, let's start with p. What is p? It's a variable, but it could be a function, it could be, so we have this generic thing called an identifier, and it's p, right? What is walk? Well, walk is a selection from an identifier. So we're selecting walk from the identifier p. Next up, what are these? Well, these are arguments that we are applying to this. So we're doing something like apply this, and we're applying a list of arguments. And then, what are we applying? What are the arguments? What is briskly? What is Main Street? Well, they're also identifiers. Right? So this abstract syntax tree is what a compiler actually sees. This is internally what actually goes on. Now, let's don't believe me. Let's actually look. Let's actually create something that. Let's take a macro, right? How do we actually look at what the compiler sees for this? Well, here, remember how I had a macro function that takes a tree and returns a tree, right? Well, let's say we have a macro function, takes some kind of tree, returns an arbitrary tree, right? This is an abstract syntax tree. That's what this means, right? Now, let's say we just have a macro function that does something very, very simple, that just says print line, string, and returns string. Or in Scala, you don't need return. You could just do that, right? Just print it and return it, and we're done. And guess what? When we pass something like this inside of this thing, this is what we should get printed out. Or let's say str.show or some nice printing function or something like that. Okay, let's try to give that a shot. All right, so let's code our macro function, which is going to be this thing. All right, so let's just do print line expression.show. This is going to be our tree. Did we forget to import something into here? Then return expression. We want it to return a tree. Let's make that explicit. And is there a show here? Oh no, excuse me. Show is a external function that's in the context. Okay, show is outside. Okay. It's whatever, just the way that works. All right. So now let's code up exactly this. Let's say, what do we want P to be? Let's say P is going to be a person. Case, class, person, name, string, right? And then we'll add a method called walk, or let's say action. Action, case, class, action. Case, class, action. And then let's say let's say action is going to be, what did we have here? Or, okay, let's say case class location. Let's actually do, let's make an enum, whatever. This is how you do an enum in Scala sealed trait. Action, and then let's do object action, and then inside you define the cases. So it'd be case object. Let's say pace, or sorry, action, which is walking, and running. Okay, this is our enum, right? And then sealed trait. What are we going to do here? Location, case, or object location, case object, briskly, right? And then case object slowly. Okay, fine. Action is of type action. And location, a person is at a location. Okay. Oh, wait, hold on. What am I doing? Location is, whoops, Main Street. That's location. Central Ave. Okay. So we've got locations, we've got actions, and then, or no, hold on, sorry. Walk is a method that we've defined here. Sorry. So we're doing pace. Excuse me. Briskly, slowly. We're just modeling data as we go. So let's say this person has a pace and he has a location. And then let's define the method walk. And then it takes a pace or a location to where to walk to, and a pace. And then let's say, immutability is very nice, so we just return a new person, name that has the new location, and has the new pace, or has the new pace and the new location. Finally, done modeling our data. Okay, so what do we actually want to demonstrate here? We want to demonstrate we have val p equals to person. Person, his name is Joe. He's walking, he's doing something. He's doing something slowly, and his location is Central Ave. Excuse me. Extends location. This is just how you model data in Scala. Extends. And these are just enums. Extends. Okay. Now, let's say we had a normal method, right? Let's say we had this normal, regular, everyday method. And our regular, everyday method, well, what does it do? Right, it takes a person. Let's say it returns a person. Okay, what can we do? What can we do with a person? We could say person.name. Okay, well, we need to return a person, so we could say person.copy, or we can change his name. Right? We can change the variables, but again, when we actually invoke that method, we don't know inside of here. Let's say we did p dot walk, and now, let's actually make the identifiers that we had. Main street equals to location dot main street. Val briskly equals to pace dot briskly. Okay. So now we said p dot walk main street briskly. Voila. Right? Do we know that this person, that p dot walk here is what actually got passed into here when we invoke this method? No. We only know the output of this expression. That's all we know. We can't say anything about what happened inside of here, which is, for most of the work that we're doing in our ordinary programming jobs, it's fine, right? We're just used to functions working this way. The lack of this visibility is what we expect. As opposed to, for certain kinds of systems, most notably transpilers like Quill that transform Scala into SQL code, we need to know more. We need to know about the expression that actually happened inside of here, right? Because, well, guess what? If we know about the expression that happened inside of here, then we can turn it into SQL, right? We need to know what happened to P. Let's say that p.walk is going to be something like select, let's say select main street briskly from person where, let's say person P, where P dot doing equals to walking. Or something like that, right? Let's say that we need to transform this kind of thing into some kind of query, where walk just means something, and this just means something, and this just means something, right? This stuff means stuff that we can translate into other stuff. Okay, right? That's all our programmatic logic. But here's the thing, again, we cannot ever produce something like this inside of here because we've got no freaking clue what went inside. Right? We don't know. Which is why we can't do that. In order to be able to do that, we need to know this expression. That's what macro methods are for. So let's actually kick off a macro method. And here's a macro method that I created here. Just takes an expression, prints what it is, and just returns it. The other part of it is that you need to define. You know how in C++ you have CPP files and you have H files? Yes, no? So, right, this here, this is like the .h file. This is the sort of the signature, the predefined signature of the macro. So in this case, it's going to be, let's call it run macro, or let's call it macro method. And this is going to be person. And do we need to import this? Wait, no. Oh, right, I need to move this, and I need to move these out of here into the global context. Yada, yada, yada. Now it should, oh, whoops. Excuse me, this is living inside of my testing code. And here, the macros don't see that. I'm sorry? I just need to move it one level up.
Just like
Okay. Sorry about that. Oh, yeah, maybe because I was creating a new file or something. Okay. All right, we've got that. We've got that macro method. So then we say process tree macro dot run. And so this object is the thing that holds our macro method, use process tree macro. Basically, this is our, let's rename this. Let's rename this to macro header. This is or we can just call it our header. Or no, macro header is fine. Macro header, and this process tree macro thing, let's call it macro source. That's a simple way of understanding it. So this is the macro source that gets invoked by the macro header. And the macro source needs to have a actual definition of the macro header's method. So that's how we do that. Now, let's actually invoke this thing. Now, the tricky part is that a macro has to be compiled before it can be used. So I can't just make a new file inside of here that uses it. I need to actually be in a separate project after it's compiled, i.e. that uses this thing after it's compiled. Alternatively, or not really a separate project, but really a separate class path. Or I could be inside of tests, because guess what? Tests are a separate class path, the way that basically all JVM applications are structured, including Scala. But anyhow, so we've tried calling method. Let's do macro header dot macro method. And let's pass this entire expression inside. What is this thing gonna do? Well, it's gonna print out dot run, excuse me, right? You need to actually, the way you need to do it is you need to say macro and then the file, the source file, and then the name of the method. Okay. So we're gonna print the expression, and then we're just gonna return it, i.e. take that expression and splice it back into the code. Now, let's give this a shot. Let's run this thing. Can I increase the font size here? Yes, I can. This is the one downside of having IntelliJ run from Linux is, of course, it will not do nice things that we're used to, like multi-touch gestures. Let's see what happened here. There we go. There were our messages. Okay, so there's what our Scala compiler printed out. p.walk. That was the result of our show method. So it printed out the code, but we didn't want the code. We actually wanted the abstract syntax tree. So I think it's show raw. Let's try that. And one other important thing to note is that when you are running a macro, if we just run this thing again, this thing will not recompile. This code will not recompile. It won't recompile because we haven't actually changed anything. And that's the trick, right? You don't see that message being printed here because this thing is already compiled. The macro is run, and it's only if we change this file that the macro will actually be rerun. So there it is. Let's go back to build, and voila. There's our abstract syntax tree. Let's see if I was right. I forgot about term name. Okay, there's one other level of detail, which is P is not just a string, they call it a term name. Okay, and then this is not a string, it's a term name. Okay, there are some more complexities, but you see the structure of how this thing works. Does this make sense so far? Okay, now let's say, for example, that in our macro method, we want to start doing things inside. The purpose of macro methods generally is to transform the stuff that was passed inside. That's kind of what they're used for. That's their practical application. Because guess what? For anything else, you don't really need a macro. You can just use regular code. So let's actually transform this expression. So let's see. Let's give this a shot. Let's say we have something like expression match, right? And we're all familiar with how match works in Scala. Okay. Well, please refer to previous videos about that. So, oh, by the way, pattern matching from this kind of construct, it already exists in C#, and it will exist in Java quite soon. So, many features from Scala are being imported into Java. This is actually one of them. Case classes in Java 15, I believe, are called record classes, and they have a pattern matching method. And they call it switch in Java, but basically they've extended switch to do more, to basically be that. Anyhow, case, let's say apply. If you have an apply of select of some ident, we don't care what it is, and let's say this select, when here we're going to have a term name of walk, and then did I make a mistake? Yes, I made a mistake. This needs to be inside of this, right there. And then, well, we could actually just take this thing here and copy it into here. All right. Let's say that what we want to do is we want to change Main Street to, what was the other thing we had here? Central Ave, right? So, but Main Street is actually an identifier. Okay, but that's interesting. Let's look at, well, before we do this, let's look at what happens when we don't use Main Street. Let's before we go further, actually, let's comment out what we just started working on. And let's say instead of this Main Street identifier, we use location.mainstreet. What's going to happen then? Well, let's have a look. Again, you have to go to the build because that's when it happens. Interesting. It's an identifier of location, and we are selecting Main Street from that identifier. Let's have a look at this. All right, now, this is an argument instead of Main Street, which was the first thing that went inside of here. Now, this is actually selecting location as the identifier, and from location, we're selecting Main Street, right? We could just do it like that. So, interesting, right? We're starting to see how trees actually work. Okay, so let's say, for example, that we started writing some code. Let's say, for example, that we want to match this particular type of expression, where if somebody is walking and the first argument is this static enum, this thing here, and all right. Let's see, this is going to be ident of location. And let's see what happens. Now, instead of Main Street, it's not going to be a term name because location is not a term. Location is a class. And the interesting question is, how do we match this thing in here? So let's do this, and let's do location. Let's say location enum, which is what we expect this thing to be. Okay, so now these are the arguments that we've applied. Let's take a look at what these things actually are. So now what we want to do, which is going to get a little interesting, is we actually want to debug the macro. Let's actually debug the macro. Now, this isn't really possible inside of Dotty, at least yet, but it is possible inside of regular Scala. So let's see if we can set up a macro debug and look at what those things are. So, and again, this is actually the environment setup video does talk about this. Application. And we have to do a couple of things here. We have to specify the main class. Welcome back. Macro source. And program arguments. And this is actually, a lot of this is in the contributing.md. These arguments are needed for various reasons, not really important to discuss what they are right now. And these are this is VM options. These are program arguments. And we have to specify the path. So again, it's going to be this thing. That's Scala. Oh, wait a minute. It's not macro source. It's actually process tree macro. Oh, but wait a minute. This is inside the testing code. This is inside the testing code. I am not sure that this will work. I think we might need to move it to the production code. Let's try it, though. Let's try it. And what is our absolute path? And again, this is all Linux paths. /alexi, right, that's where we are, / I believe we're in Git. And then we are in macro test, or macros intro. And then the full path This is our C main Scala. Com test example. Actually use process tree macro. That's Scala. Let's see if this will work. Otherwise, we'll have to. Oh, set a breakpoint. Oh, right. We have to force the macro to recompile. Force the macro to recompile. Let's see if this will hit it. No. Debug macro. Looks like it's not grabbing it. 1 second. Use Java CP combo tested example actually. Process tree macro, CP. Test example actually use process tree macro. Get macros interest or cmain Scala contest example process tree macro.scala. And okay. Oh, and we also have to set to build no error check, and in case the macro internally fails, we don't want to stop the compilation because we want to still debug the macro. But anyway, I am not sure why this thing is not. I'm not sure why this thing is not kicking off. Oh. Well, it got into here. Oh, whoops! I forgot to write. Right, we're not actually. Super important. We're not actually debugging. We're not actually debugging our application. Because the macro runs inside of the Scala compiler, we're debugging the Scala compiler itself. That's when the macro is actually created. So, super important thing to keep in mind. Anyhow, let's see if this works. Oh no, this is what I expected. Wait, hold on. The global overrides final method phase with ID. Scala tools.msc.global overrides phase with ID. Wow, this is the first time I've seen this particular error. I'm going to look this up because this is not something I've ever seen before. Code generates below stack trace. Verifier, okay. Oh, Java lang.verify error. Phase with ID. Let's check what version of Java we're running here, just to make sure. File, project structure, running Java 1.8. What's Scala SDK? We're running 2.12.12, which is also correct. Oh, wait a minute, what? Oh, whoops! And here we're claiming that it's actually Scala 2.11. That's the problem. So we're running a different Scala SDK inside of here. Well, that makes sense why things are breaking. So in this case, let's change the POM file to use the right version of Scala. The thing about Scala dependencies, if you're running them in Maven, is that you need to actually have the major version of the Scala library inside of the dependencies themselves. So you actually have to specify them there. So that's actually because the Scala library is used for the dependencies themselves. And okay, 2.12.12. That makes sense. Okay. Maven, re-import. Let's try this again. Oh, there we go. It's compiling. And now we're getting dependency resolution errors. Why are we getting dependency resolution errors? Oh, because it's a Quill version that's too early. Let's do 3.5.3. Let's try that again. Could not load or find main class scala.tools.nsc.main. And now the other problem is we're using Maven, so we need to import the Scala libraries into here. So we've got some other dependencies here that we need to do in order to be able to actually debug our macro. In Quill, by the way, this has mostly already been done. So let's say GitHub, and we need to import, in order to be able to run a debug on the Scala compiler main loop, we need to include the Scala compiler itself as a dependency into the project. This is yet another interesting quirk. In Quill, we actually have a special argument that drives that. So let's do that. Yep, this is Maven. And this is going to be 2.12.12, Scala library, Scala compiler, and Scala reflect. This is just a quirk of Maven. Okay. Re-import into Maven. All right. Let's try to run this thing again. Error, IO error while decoding with UTF-8. Oh. No such file or directory. Let's double check that this actually exists and that I did not make a mistake in this path. Oh, I did make a mistake. Where did I make a mistake? Macros intro. com.test.examples. com.test.example. Well, this won't work well. Oh my gosh! Look at that! I can even click on Show in File Manager, and it'll launch the X Windows File Manager. Look at that! Uh, so this is just X Windows. This is the X Windows file manager. That's all. That's pretty neat. And I can actually, by the way, I can browse the Linux file system in here. It's not, very good UI speaking, but I'm sure you could clean that up. But anyhow, that's an interesting quirk. But anyway, why actually use process tree macro? Why? Let's see. Oh, wait, com test example. Ah, this is src main. It has to be src test. Yes, so I did make a mistake. It has to be src. What? Okay. And voila! There we are, inside of our macro breakpoint. And we are actually debugging our macro right here. Run. I have not set up my. Let's see, step out, resume. Oh, resume as F9. Okay, so let's take a look at these variables. Let's see, do we have them? Ah, we need to actually do something with them. Let's see if we've matched this clause. F9. Oh my gosh. Does this thing, sorry guys. Oh, I think F9 also F9 also pauses the recording in Camtasia. Oh, too many hotkeys. Too many hotkeys. Okay. Resume debugging. Let's actually print these out. That's what I intended to do. I wanted to actually see originally when we started this, before we ran into all the issues that we ran into. I wanted to see what this thing is. Right? When we actually said this, what did we mean? What is this? Right? What is this identifier? What is this identifier? So let's actually println location, println concrete. Okay. Let's actually look at what these things are. That was my entire purpose of doing all of this. Okay. Okay, there we go. So, what is this? What is this? Ah, interesting. This is a term name as well. It looks like it, at least. It looks like this is a term name, and it looks like this is a term name also. So let's see if this thing actually does what we expect it to do. So this is going to be, so this in fact is going to be term name location, and this is going to be term name Main Street. Let's see if this is actually true. Oh, by the way, these variables no longer exist, right? Because we filled them in, right? A second ago it was this. Oops. But now it's this. Can anybody tell me how to get these back? Anyone? How do I get these? Remember the remember the at symbol? Yes. So make sure to go over the lecture where I did pattern matching, and that's the advanced conditionals lecture. It's lecture sounds so official. uh, Here, 1 second. This guy here, Introduction to Case Statements, where I actually talk about all of these different things. So, if you want to brush up on how this thing works. Anyway, again, we have to change our macro, and let's try to debug it. Let's see if we hit that breakpoint again. There we are. Now, here's the interesting part, right? What we can do is we can not only hit an expression based upon certain code that happened, we can actually change the code. We can actually modify it. That's sort of the whole point. So let's say, for example, that if we know that somebody is walking to location.main street, let's change the location. How do we do that? Right? What we literally want to do, this is what macros allow you to do. They allow you to say, if you see this code here, change it, take this code, and splice back in instead this code. That's what macros allow you to do. What do? Right? Well, we've done half of it here. We've selected the darn thing. Now, if we match this thing, well, guess what? Let's have this, our original identifier ID. Oh, or we just grab it from there. Now, here's what we'll return. Let's return this, our original identifier, ID. And, oh, that won't work anymore. And our new location, what's the new location that we want to use? What's the new location that we want to use? Central Ave. Okay, just wanted to double check that. So anybody who's going to Main Street is going to be going to Central Ave instead. And, oh, need one more parenthesis here. Two more parentheses here, excuse me. Okay, so basically, when we see, right, we see location is Main Street, we're changing location to Central Ave. Oh, and by the way, also print line, case matched, changing location. Okay. And we don't care about that anymore. So let's try it. Again, we have to modify the file. And let's run it. Oh, of course. So the case matched, we changed the location. And actually, let's print out, here's what I want to do before we actually run it. All right, here's what I want to do. Right, we need to print out this new thing that we returned. So if we actually match this thing, then return this new code. Otherwise, return whatever we had before. So let's show raw our initial expression. Let's indent all of this. Our initial expression. Then print output expression and return the output expression. Okay. Oh, and by the way, in Scala, you can do string interpolation, like that. Dollar signs are a nice thing to have, so you can just do that. And it's actually, I believe it's more efficient than the plus. Anyhow, let's, again, change the code and give this a shot. Okay, here's our initial expression. We were going to Main Street, now we're going to Central Ave. Ooh, interesting, except that we need the full path name. That's interesting, right? Because we changed, let's see, we changed it to the location here, but this needs to be the full path name. Let's give this is interesting. Let's give this a shot. And let's actually, so this returned a person, right? This whole thing, right? When it gets an expression like this, it's going to splice it, right? And this expression here is what's inside here, right? So when this function, macro method, when it gets this expression here, it's going to take it, and instead, it's going to splice it and return this. You can imagine literally the macro rewriting our code from this to this. Okay? So that's what's going to be the result of this expression here, right? Because that's what we do in macro methods. Now, let's attempt to run it. Okay, we ran it. Sorry. One other thing, right? Let's actually print out the result of this, right? This is going to be, what is the result of this thing going to be? Right? Well, what's the result of this expression going to be? What's going to be the result of person.walk to Central Ave briskly? Well, let's just look at what that code means. What is that code going to return? Person walk to a location to Main Street briskly instead of slowly is just going to return a new person object with those variables, right? So we should just have a person object that gets returned, right? That's what this whole expression here, that's what this returns, right? This is p.walk to some location. What location? Central Ave, right? Location dot Central Ave, briskly. Or if you'd like to see this more clearly, right? What did we match? This thing up here is p dot walk, right? P dot walk. What's this thing here? That's location.Central Ave. What's this thing here? This thing here is briskly, right? This, right? It matches, matches that part of the expression. This over here matches that part of the expression. this over here matches that part of the expression. Well, what does it return? Well, this thing over here, again, this thing over here returns that thing. And this thing over here, excuse me, this is not Main Street, this is Central Ave, right? Location dot Main Street. Okay. And in fact, we don't need these at things anymore. Notice how they're gray. IntelliJ can even tell you we're not using these variables. Therefore, we'll color them gray. Let's line it up so that I guess it's nicer. Okay, now, right, this is going to return this part. This is going to return this part, Central Ave. And then this part at the bottom is going to return that part. What's the result of this expression? What's the result of this expression? Like when this thing actually gets evaluated during runtime, what's it going to be? Well, let's look at what this code actually is. This code is a new person that is in the location at the pace that he's doing something. So that's going to be person. His location is going to be central, or he's going to be, well, whatever was passed in, right? And it's going to be location and whatever briskly, because that's what we had here, and that's what we're returning here. So that's what we're going to have here. So something like this is going to be our return, because we're basically, the macro is replacing this code with this code. So our return is going to look roughly like this. Okay, does that make sense?
Yeah, Alex, just a quick question, like more about the structure of it. So, whatever code we write, it gets embedded into this tree, and we're essentially returning a new tree that's fine so far. Who converts into this tree first of all, and then, this is a question. I was going to ask you about the compiler, and then this is essentially the input of the compiler, right?
Yes. So the
And then who converts our code into this ASD?
okay. The Scala compiler, right? Every single compiler has a parser.
Oh, okay. So it's part of essentially part of the compiler.
Yeah,
So one part of the compiler just looks at the code that we write, converts it into the ASD, and then essentially takes that the other part of the compiler takes this ASD as the input, right?
correct.
Okay.
Yeah. Um, yeah, so every compiler has a parser because a part of the compiler literally needs to parse your code. Any other questions?
Well, technically, we do have a little list of questions here if anyone has any.
Oh,
Uh,
so why don't I wanted to get somewhere with this. And then is it like general questions or what is it?
yeah, they're pretty general questions. We have a little section called questions where we could ask
Oh,
questions.
I'm so sorry if I missed some stuff there.
No, no, no.
Okay.
Pretty much anything really. We're just keeping note of them so we can ask you later.
Okay, okay. Maybe I could like finish once what I'm going through here and then I can
Yeah,
go through. Okay, okay, sure. All right. Any questions about this? Sorry. Either I'm being totally clear or totally confusing. Okay, cool. Thank you. All right. So, something like this is going to come out. Well, let's just print it, right? It's going to come out of here. It's going to come out of here. So we can just print it. Or we could just print it right here. So let's print the result of this. And let's go. And let's see. So here's our compiled code, right? Our initial expression, our final expression, but what's the result of our runtime? Ah, we actually need to run our code, right? Because in here, we're debugging the Scala compiler. We're not running our actual code, right? Because the main class that we're running is the main class of the Scala compiler. We need to run the main class this, right? We haven't run this, so let's run it. And there we go. Our person, Joe, walking briskly to Central Ave comes out. Now, okay, so we managed to manipulate this tiny bit of code and change this tiny bit of expression logic, but this is kind of verbose, isn't it? Like, ideally, if I want to change some code, I'd like to be able to say something like, well, case, I don't know, some p dot walk, maybe make that into like a variable that I can pull out somehow, location dot main street, and then briskly, right? Maybe like that. So, so, um, right, that would be nice to be able to say, okay, when it's something like that, then maybe change it to something like that. Right? This is basically what we want to achieve in all this gobbledygook that we did here, right? Because this is kinda nutso for matching something so simple. Does that make sense? Hence was born the capability of in Scala to do this thing called quasi-quoting. Quasi-quoting lets you do almost this. Quasi-quoting works like this. You do Q, just like in Scala, you can do this S, right? And then you can use these dollar signs in a string. Quasi-quoting lets you match things with this Q. And same thing here. Let's do Q. Braces? Oh, you mean here. If it's, um, if it, yeah, if it's if it's a very simple method, it's not needed. If it's a very, very simple method. So, excuse me, that's not needed. Right, so that's quasi-quoting. Oh, right, this internal thing is not a case, it's just our output. So, this is basically the same thing. Now, I'm not sure that this will work. Let's give it a shot. The thing about quasi-quoting is that, unfortunately, it's a little bit finicky. And so quasi-quoting is how they made the API for matching expressions and returning expressions. Notice how this is an API for matching an expression with quasi-quotes. This is an expression for returning something using quasi-quotes. But they're finicky in terms of how you need to use them. Sort of things that you expect to work, kinds of expressions that you expect to work, don't always work. So let's actually give this a shot and let's see if it works. Otherwise, we'll have to mess around with it until it starts to work. And 1 second. Okay. Oh, right. And I do have an extra curly brace right there. Is that what you were referring to? No. Let's see. Oh, there we go. It actually did work. Cool. Right? Now, here's the interesting part, right? We can actually pull these things out. Like, say we wanted to pull out this location, right? We wanted to do, or in fact, we can actually pull out something like P, right? We can do something like, let's say P dot the type. What is the type of P? And let's print it out. I think to actually get, well, let's see, print line the type, and then the widened type. And let's see what happens. Again, got to change the file to make the macro recompile. Oh wait, hold on a minute. I am running our file as opposed to running the Scala recompilation. But actually, the why isn't it's annoying that yeah okay there it is. Run. Is there messages? This thing, when you actually force it to recompile, it should recompile. It should actually, and then when it does, it should give us a log, but it looks like it's not doing that. I'm not sure why. Let's try doing this though. Okay. Now here's the interesting part. So we want to know the type. That's what we were trying to find out here. What's the type of this expression P? The type, interestingly, was P dot type. Okay? What the hell is that? So this is one of these things where the meaning of P dot type, by the way, type is a keyword in Scala. It's an actual keyword. Like when you do something like, do we have ammonite here? We should have ammonite, right? Case, class, person, name, string, age, int, right? And then we do val p equals to person, Joe, 1, 2, 3, p dot type. Type is a keyword. Or will this work? Expected an identifier. Let's see, person dot type. Oh, excuse me. Ha 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 ha. You can only use this inside of a generic. Right. I'm sorry. All right, so you have object. Let's have red. Let's leave that alone for a second. When you do something like def something and you want to pass some type t into it, and then you say this thing, I don't even know, does nothing, let's say, right? Something of person. Well, it doesn't actually do anything, but you can pass person. You can't pass red, because red is an object. It's not a class. It's not a type, so you do dot type. And I believe you could also do p dot type. Right? So what you're saying is it's the type of this variable. This specific variable, it's the type of it. Why is this important? Why is this needed? Well, here's why. Because when you define P, you could do something like this. And this is called a refined type. This is called a refined, oh, wait. Person does not take parameters. Oh, excuse me, like that. Excuse me. Right? And then you can actually do P dot additional stuff. And this is a capability that Scala has, which is unique. There are some other languages that have it. Java does not have it. You can't declare, well, you sort of can. You can declare an ad hoc class that has additional functionality, but it doesn't have, Java doesn't really have the notion of being able to declare a refined type, right? What's the type of P, right? Let's say val pp equals to new person Joe 1, 2, 3, right? You can't do pp dot additional stuff because additional stuff wasn't declared on this guy. It was declared on this guy, but you can actually do it. Now, when you declare something like this, what is the type? What is the type of this thing? Well, here's the type. It's the person class with some additional crap inside this method, or it's some additional crap inside of him, right? That's what it actually is. So when you do p.type, and you actually want to say, have a method and put the method into the whole, right? What do we, when we define a method, it takes a T. What do we call this? We call it a whole, right? It's a whole that takes a type, or a type whole. So when we put something into the type whole, and we want to put the actual refined type of this variable, it's that. And so when the compiler, when you tell the macro engine p.type, it's the actual type of this variable. What's the actual type of this variable? It's p.type, right? Because it could be refined. But if you widen it, remove all the refinements, then it's like, okay, we are com.test.example.person. We're the person class. This is something about type. So we can look at the type of P, right? But here's the thing. This quasi-quoting lets us do a lot more. Let's say we want to do location, LOC, right? And then we can do things with this LOC variable, right? We can actually say, what did we say? LOC was an ident of term name or something like that, right? We could say LOC, or let's do yeah, let's LOC, right? And this is a tree type match case ident, right? And we can actually mix and match this kind of way of doing things and this kind of way of doing things. So then term name tn, let's say, yeah, term, or something like that. If term, we can put if statements inside, if term, if, oh, no, excuse me, location is a select. Excuse me. Location is a select. So we have to match this entire clause. Let's call it, well, this, let's say we don't care about, but we want something like this. And then let's do term. Term in here. If term dot starts with main, oh, then let's say if both of these conditions are met, then we want to change it to location.centralav or something like that, or if it starts with main, right? Otherwise, let's return the expression. Okay. So we've basically, this is more powerful. We can already start reasoning about stuff that's inside of these variables, and we can start pulling out stuff inside of them. So let's actually try this out. All right, whoops, I need to force it to recompile. And let's see. Oh, looks like this did not match. Let's see, location, oops. Location match, case, select ident term name. If term dot starts with main. Looks like this is not even matching. Okay, let's try to debug it. Oh, excuse me. This statement is going to blow up if it doesn't match. So let's do println. Oh, also, this expression is going to return whatever happens inside of here. Because we're not actually returning what's happening here. Okay, let's return what happens here. Output equals, oops, output equals to that, and then return our output. All right. Or, in fact, we don't have to do that. We can just say the return of this expression is what we want to return, right? If this expression is the only thing inside of this case, whatever this expression returns is going to be the output. So you just do that. So now let's do case other print line did not match expression. And then say returning initial expression. And let's try to run this thing again. Oh, we matched it. Okay. But because we actually didn't return it, we didn't get the right result. Now, right, this logic is a little bit more generic. So what's the whole point of this? We can say main street and main Ave, right? Everything that starts with main is going to get returned. So let's change this from main street to main Ave. Let's run it. And there we go. We're going to change main to central. So basically, this is you mix and match these kinds of expressions to return other things. Now, in the Quill Parser, you actually only do this part. You don't do this latter part. This is most of what you're going to do is stuff like this. So if we look at the parser, the vast majority of the parser is matching. What we return from the parser is Quill's abstract syntax tree, right? So, for example, and let's actually, where do we have this? Right, this is a compiler. A transpiler like Quill, what does it do? Instead, a transpiler like Quill, instead of returning, can I draw on here? 1 second. Jamboard. Introduction to Quill. 3 out of 4, 4 out of 4. This work? Yay, it works. What a compiler will do, i.e. the Scala compiler, or any other compiler, what a Scala compiler will do is it'll take code, it'll translate it into an AST, into a Scala AST, right? And then it'll transform it into another Scala AST. And that's what the macros will do, excuse me. Or actually, let me step back for a second. It'll transform it into an AST. And then what'll happen eventually is that it'll be transformed to machine code. Where do macros fit in? Macros fit in between here, where we transform it from one AST, from one Scala AST, into another Scala AST. I love being able to move stuff around. Anyway, what does, oh, by the way, this clause in here, all of this stuff in here, is a macro method. What Quill does, right, is Quill lives inside of this macro method. What does it do? You have your code, your Quill code, right? It turns into a Scala AST. That Scala AST will then be taken and processed by the macro, by the macro processor. And these Quill macros will eventually reprocess things into a new AST, but a new Scala AST. But before they do that, they'll translate the Scala AST into the Quill AST. And eventually they'll translate that Quill AST into a different Scala AST. And that will eventually get translated into machine code. And embedded into this new Scala AST will be your SQL query that you want to execute, plus your executor that is actually going to execute it, right? So that's where, and by the way, all of this is inside of the Scala macro system, all this red stuff. So now, the parser in particular is this part of the show. Oh, let's have blue stuff. The parser is this part of the show. It translates the Scala AST into Quill AST. Now, the second part of the show is the lift/unlift. It's the job of the lift/unlift to transform the Quill AST back into Scala AST. Sometimes back and forth a few times, actually. And we'll talk about that later. But anyhow, most of what you're going to be doing is working on this parser. So that's why when you actually look at this parser, right, this is a Quill AST element. This is a Quill AST element. And if you actually go to this ast.scala in here, you'll see these are Quill AST elements. So basically, this is the parser that you're going to be working with. And so basically, the task is to take this parser, and to take these quasi-quotes and translate them into the upcoming Scala 3/Dotty macro system. And the challenge is that Dotty does not have quasi-quotes. It doesn't work with quasi-quotes. There is a new kind of quasi-quoting system that is going to be in place in Dotty. And it works similar. It works similar to quasi-quotes, but it's basically quasi-quotes reimagined. Notice that all of this is inside of a string, right? What is the type of this thing? What is the, well, you could do blah, 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 right? And guess what? This is completely unsafe. We don't know what blah, blah, blah is. There's no notion of what that thing is. And so when you write this thing as a macro author, you kind of have to make sure that what you're doing here is right. Or else, guess what? The compiler might not even be able to catch it. You could even do something like that. Sometimes you'll even compile it, and only during runtime will it be caught. So quasi-quoting is fundamentally unsafe. That's why in Dotty, and this is a new macro system that they've been writing for the past several years, what they've done is they've completely reimagined the system, where what actually happens inside of this thing here, inside of the quasi-quote, is actually legit Scala code. And what that Scala code actually looks like, let's go to VS Code. Let's go to an example. What that actually looks like is this. Can we make this bigger? Come on, plus, there we go. Okay. Let's actually, notice how this is the header, this is the source. So the way that the source and the header of the macro work are a little different, and they can actually be in the same file, but that's a minor detail. In Scala, the way that it works, in the new upcoming Scala, the way that it works is it will no longer be something like this. Instead, the way that it works is that we have this very, very interesting quote operator, which basically says, this is a quotation. You know how Quill has the ability to say, right, IV, okay, sorry, no, I can't show that there right now because I don't have a history. Quill has the ability to say something like case class person, name, string, age, int, and when you do something like query, you do quote. And it's query person, let's say dot filter, p2p.name equal to Joe. What is quote, right? We can run this thing. We run this thing, and during compile time, it evaluates this expression and actually gives us the SQL select p.name, p.age, from person from person p where p.name equal to Joe, right? It'll do that. But what's quote? Quote, in a broad sense, quote means that everything between this bracket and this bracket is something that is an expression. We treat it as an expression. The result of this is not going to be query of person. The result of this is actually going to be quoted of query of person, or alternatively, expression of query of person. So you're actually taking some code and you're creating an expression of it. So what this means is you are matching an expression, and what is inside of here is going to be legit Scala code. It's actually going to be p.walk. You can still use $signs to represent variables. That's still possible. But here, right, when you just do location, that doesn't work anymore. And the reason why that doesn't work, or in fact, even this doesn't work anymore, because this is a variable and we have no idea what its type is. And so this is going to cause a compile failure because we need to know what the type is. How do we know what the type is? We need to actually specify inside of this expression what the type is going to be. And that way, the entire quasi-quoted expression, or whatever you want to call this kind of syntax, if you specify the type in here, this entire expression is now type safe. Also, you have to do something like that here, where you specify location. This syntax of doing something colon something in Scala is called type ascription. Now you can do this in normal Scala code, by the way. You could do trait, animal, let's say trait animal, case class, cat, extends, or let's say cat extends animal, right? And then you could do, let's say, val p equals to new cat type ascribed animal, right? Now it's going to be an animal. Normally, it would be a cat. So it's called type ascription. So you use type ascription to actually define what the types of the variables here are expected to be. Say briskly, and again, what is this? Where is this supposed to come from, right? Like we said in here, oh, this is something. This is something. What is it? How do you define it? So in this case, you actually have to have some kind of way of defining it. This has to be some kind of expression that this part of the code knows about. This has to be some kind of variable that's defined somewhere. Maybe it's an identifier. It could be an identifier, right? So what you could do is you could specify that briskly is an identifier with that particular name. But again, you have to specify the type. And the way that you have to do that, is specifically, if you want to do something like that, you have to tell it, right? What you're trying to say is this is an ident like that. Now here's the thing. Again, what is the type of this ident? What is it? Just an expression like that indicates that it doesn't know what that is still. And so what you need to do is you need to actually make a type ascription here. and you need to actually say, no, 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 no. This is a pace, like a walking pace, right? Because that's the way that we defined this variable before, right? Inside of this method here, it's a pace, right? Oh, now there's a problem because this is actually abstract syntax tree code. This isn't Scala code. You can't just shove it into here. You need to actually have some kind of conversion between Scala code and abstract syntax tree code, which is why which is why there are some other artifacts. There's something called seal, where what seal does, this idea of sealing a variable, is basically saying, okay, this is some code that is an abstract syntax tree that I am creating, that I am shoving inside of this kind of statement. But anyhow, I don't have time, right now for today to get into this, but this will be the next lecture where we will actually look at exactly how to do this, but in the new Dotty Scala syntax. So let's end here, and if you guys want, I can take some questions, or we could call it a day.
Well, can you look at some of the questions that
Yeah, yeah,
have
yeah.
come in
Sure,
so
sure. All right. Yeah, sorry for not responding to them in general, but I will endeavor to do that. Okay. All right. Why are nested hierarchical situations so common? In what sense?
who asked
I'm sorry?
that was the question about flat math. Like my question of why is it so common to like eliminate queries that we have to condense it into a single like whole line expression? Like why don't you fix one of the side of things instead of making a code basically? Or
So I gave a talk about this actually at the Philly Scala enthusiast group. Great group actually. You guys should come to our talks, although with COVID, they've been on pause for a while. So I've got a talk on that where the long and short of it is that, in most industries these days, especially in the B2C world, sorry, the B2B world, business to business, right? There's business to customer and there's business to business. Much of the financial industry is business to business because, firms sell products to other businesses. Also in the life sciences, it's business to business. B2B data is freaking complicated and it's extremely domain specific. Um, you know, I've at Nasdaq, for instance, where I decided to sort of go in this direction with these query transpilers is because they gave me a product um, that had hundreds of SQL queries, half a page to a page long, and I looked into trying to simplify them. And sure, there are always ways of simplifying them. There are always ways of simplifying them. But fundamentally, there is a simple problem. There's a simple problem with SQL in general. And the problem goes like this, right? What happens is you can have some kind of select, let's say select name, age from person, right? And okay, so we have people that are going to be a customer group. And then this kind of query is going to drive a whole suite of products. And then suddenly, we have a new line of business. And the new line of business is going to have something like this, right? And so we're going to have a new sort of way of querying things, except for it's going to have like a slight change, something like that. Right? And then they're going to have another line of service where it's going to be something like that. And what's going to happen is that these queries are obviously not going to be one-liners. There are going to be many joins involved. And there are going to be many tables that get joined. But at some point, fundamentally, what you want is to be able to say, no, we want some polymorphism. We want to be able to define some kind of class customer that has some kind of label representing the name and some kind of something representing the age, or something like that. And what we want is we want to be able to create some kind of function that lives inside the database that takes some kind of customer class and then does c.join with all of our other business data and is able to do this in a polymorphic sense. The problem is that this kind of interface doesn't exist in any database, in any SQL dialect, ever. With Postgres, with any element, you can do a couple of hacks. With SQL Server and table routines, you can do a couple of hacks. And they all involve nastiness with temporary tables and that breaks the optimizer. The fact is this interface doesn't exist. You cannot do polymorphism in databases because databases don't have a polymorphic object system. No SQL database has a polymorphic object system. Because if they did, then optimizing them would be immensely hard. How do you optimize a query where the stuff that goes inside you don't actually know the type of what it is? So SQL has decided not to build stuff like this. And so because SQL databases do not have this kind of polymorphism, and again, this is typically going to be something that goes on for half a page. Same thing with this guy and this guy. And the fact is that because you can't use polymorphism, you just can't abstract this. So, yeah, inside of here, and separately inside of here, and separately inside of here, you can do some simplification, but fundamentally, you cannot take all three of these constructs and make a single polymorphic thing do all of them. And this is actually why I started going along the lines of Quill and similar frameworks, because I realized that this is really, really what we need to make our lives simpler with SQL. Does that make sense?
Oh yeah, yeah.
Okay. Um, all right. What is sum versus option?
Oh, that was I think that was just that option.
Sum, yeah, sum is a subclass of option. Basically, if you do something like sum of, let's say, hello, that's a subclass. If you do option of hello, that happens, but when you start comparing them, let's do this dot equals option of hello, they're the same thing. So sum is actually a subclass of option. You can look at the implementation. Um, oops, classes. Uh, I don't have a source code. No, some and none. Those are the only two. Sorry, I just
Oh,
can't.
is it the only two? Oh,
They're the only two. Yeah. Uh,
yeah, that makes sense.
um, why do I not have? Why do I not have? Second Scala SDK. Why do I not have the... I don't know why I don't have the source code. I don't know why I don't have the source code to this thing. Download? Okay. Yeah, I don't know why I don't have the source code to this thing, but whatever. You can look at. I'll have to figure this out. In the interest of time, I don't want to bang my head on this now. But so yeah, you can actually even see it right here. Right, option has two implementations. It has. No, it's not shown here. Sorry, wait, is it?
That's fine. That's fine.
Okay. Well, you can. I'll show you the code later. You can do. Yeah, that's those
Yeah,
are.
yeah, I'll look it up later.
Yeah. Okay. In the macro example, what is single quote? Where's which one? Oh, was it was it the one with VS Code? Was it this guy here?
It was somewhere single quote and then. Oh yeah, nah, you can actually see that in the case.
Did it look like this construct? I think macro example is this thing here.
I think that's the one.
Yeah.
I watched the video and yeah, I think sometimes it might have been a different thing. Quote and then single open quote.
Okay. So, oh, here's a single open quote. There. So this is equivalent to that. Only you don't need brackets when it's just, when it's just like simple text and some numbers at the end.
Wait, I'm sorry.
So look at an interpolator, right? Let's say you can do string interpolator. Let's do val foo equals to bar, right? And then let's do an interpolated string 1, 2, 3, foo, 4, 5. Okay, it's going to splice bar into this string. Now, that's still fine. The second that you want to do something like to uppercase, well, it's like, no, sorry, I can't do dots. So that's when you need to introduce braces, right? So long as it's just simple text, and even you could even define val foo 1, 2, 3, right? You could even do foo 1, 2, 3. Still fine, right? But again, the second you want to introduce dots and other stuff in here, that's when you need to do braces. Okay? Does that make sense so far?
Yep.
The same rule applies with these little quote thingies, right? This doesn't work. In fact, you can even do case blah. This is actually not.
Yeah. Well, I understand that, but the string that's input, what does that mean? Is that quoted?
Yes, it is a Dotty quoted expression. this would be fine, but it's not legit because, again, it doesn't know what the type of this thing, so you would need to actually introduce a type here. But again, we'll talk about this more next time. Yes, yes. So what does this fundamentally mean? Right? Let's just say we have some var val p equals to, let's say, person, right? And then let's say, what is p? The type of p is person. What is the type of quote p? It's an expression of person. Just like, again, p is person, quote of p, if it works, is quoted of person, right? This is Quill quotation. This is Dotty quotation. Huh?
I just wanted to write this down. That's all. I think
Oh,
single quote, it just means quote.
yes, yes. Yeah, it means a quoted expression. And that's what actually all of this, right? All of this, yep, quoted expression. Um, any other questions about this? And again, I'm gonna go through this much more next time.
There are a couple more. I think
Let's see. What are these operators? So these are, again, Scala has no operators. It just has functions, but they look like operators, so we can call them operators. These are types. This is how, for example, you check a type. Um, for example, if you want to check p.tpe, or let's p.tpe, let's say we want to check if it equals to person. Well, usually it's going to be type of person. That's how we check a type. Now again, remember how p.tpe is actually going to be p.type, right? Because it could be refined. So what you typically want to do is this. Almost always you want to do this. Is it a subtype of person? So that's what these two things mean. It means it's a type or a subtype. Does that make sense? Okay. Next up. Go over seal. Next time. Next time. Yes. Seal and unseal are new constructs in Dotty that, again, require some background. Okay. Anything else? All right. Well, please, if you've got any other questions, don't hesitate and please put it up. I will endeavor to make more of an effort to answer them. Um, and let's figure out when we're gonna meet up next time. I'll propose some times. Preferably sooner rather than later. I want to get some inertia going. Um, you guys are gonna be really busy with finals within the next week. Okay. Um, when is like the first good day? Okay. Would Okay. Yeah, I can do Thursday evening. Would 8:30 work? All right. So I'm sorry? Okay. All right. Well, I will. Awesome. Let's do Thursday at 8:30. and let's get some inertia going, and I'll be talking about how this stuff works in Dotty. All right, guys, have a good night.
You as well.
Thank you.
Thank you.
All right. Okay. Bye-bye.